All right. Hello, everyone. Welcome to the 2021 Declaration Week Geomatics Engineering Info Session at York University. I'm your host, Hashir Jamil, and with me helping out is Vincent. And we have three panelists here today for you representing the Geomatics Engineering major. I'd just like ask our panelists to introduce themselves. We could start with Sunil.
Sure, Hashir. I want to thank you and Vincent. And it's nice actually to see faces because we just tend to email with people. And especially with COVID, we don't actually get to see people. So we really miss that contact. And so it's actually nice to see these great faces with lots of energy. So we appreciate that. So my name is Sunil Bisnath. I'm a professor of geomatics engineering. I'm in my 15th year now at the program at York, so I predate Lassonde, well before Lassonde. All of us do. My research area is GPS and satellite navigation, so I teach courses in that area. Actually, I just finished our third year core course in satellite navigation systems, in case people were interested. So we have courses like that in geomatics, and I think it's one of the really great things about geomatics. We use some fantastic technology in all kinds of different ways, and people might not know that at York we have undergrad and grad courses in satellite navigation. So we have a fantastic program. I think it's a great secret, and we want to make it less of a secret. We're always looking for great students at the undergrad and grad level. The industry is always looking for people. There's a consistent shortage of jobs of all types, whether it being in land surveying firms, engineering firms, consulting firms, development companies, software-based work. It runs the gamut. Our graduates do all kinds of different things. Very passionate people. So we're here looking to answer your questions and hoping you all come and join us in the geomatics engineering program. So thanks.
Next, I guess I could have Kostas. You could go ahead and introduce yourself.
Hello, everybody. My name is Kostas Armenakis. I'm professor at the Geomatics Engineering. I'd like to thank Hasir and Vincent for organizing this event. And most of it, I'd like to thank all of you for taking the time to find out about the Geomatics Engineering program. My area of expertise, as you can see of my background, deals with information from imagery. And one of the applications is to use small unmanned aerial vehicles with cameras and laser scanners that we can produce maps. We can generate maps, and we can determine, object coordinates and define other information that we are looking for. I teach photogrammetry, which relates to information from imagery. I teach also digital terrain modeling, so how we model any surface, right, starting from the terrain, because geospatial information is our bread and butter of geomatics. As you know, geomatics is the science and technology of where, right, location. And I also teach hydrography. That means how we can produce hydrographic, how we can do hydrographic measurements and produce nautical charts. So I hope you will enjoy that session, and we're looking forward to answer any questions. And of course, as Anil said, there are great opportunities for this profession, right? Actually, our graduate students get more than one offer, 2 and 3 offers. Thank you, Hasir.
Okay, it was lovely to hear from both of you. And last but not least, I'll have Gono Son, professor who joined last minute because, he didn't want to miss out. Go ahead and introduce yourself, please.
Me. Okay, so hey, everybody. So my name is Gunho Son, and associate professors in geomatics engineering. And so I'm really, really happy to have you in these sessions. I hope you find a great interest in geomatics program. And me, I am data scientist. I don't know if this is a good definition of my area, but I am dealing with the data and image. And one put is a sort of a computer science, but what I like is I'm working with the civil engineers, and I'm working with transportation engineering. I'm working with autonomous driving, and I'm working with the UAV companies. And all these people are cares about the cities and critical infrastructures and environments. I always enjoy geometric engineering because I don't want to be sit in the office all days and I'm studying the data science, but also I'm participated in travels and field surveyings and addressing the city problem, right? So that's what I really, really like these programs, right? This is very brief and one part of the geometric engineering. So my name is Genos, and if you have any questions, I would love to answer to your questions. Okay.
Okay, so we were asked before this started to also kind of explain a little bit about not what the field is, but how kind of the program is from the student perspective of geomatics. One thing I'll have to say right now is there's no upper year geomatics student here right now because all of them have class right now. It was very difficult to find a time where first year students don't have class and upper year geomatics students don't have class. But my good friend and colleague Timothy Kehoe, he has basically asked me to speak on his behalf and, kind of uh, say this. Geomatics engineering at York is one of the older programs. It's very small, but it's like a very, very small, close knit and tight family. You will go to classes and you will not want to miss them because they're almost the smaller than, your maybe even your high school classes. You will be really, really interacting a lot in these classes. You will know everybody. Your professors will ask you questions even. And it really does kind of dispel that myth about university just being big classes and no interpersonal involvement. If you really do want to kind of pursue that side of university where you're almost like in a graduate style class in undergrad where it's small, focused, and very, very like a family almost, then this may be the program for you, provided you are interested in the technical and scientific side of things that do go along with it. So I think with that in mind, I think I can get people excited about joining geomatics because you will get that close one-on-one interaction with your instructors and peers that a lot of the other majors just cannot have due to the numbers and lack of resources. And I don't know, how were any of our panelists kind of have a little bit more to elaborate on that? How do you feel in your classes when the sizes are a little bit smaller?
I can comment on that. I think we all can. What Tim had said to you, I think is very appropriate. Actually, I just finished a class with Tim, and he's sorry that he can't join us. Yeah, I mean, what you will tend to see in classes are small enough groups where we get to know the students, and because each of the professors you have online plus the rest of the faculty complement teach a number of courses, we get to see each of you more than once. Not so much in first year, a little bit in second year, but in third and fourth year especially. So we do get to know the students quite well, and we keep in touch with many of them. I can speak for my colleagues where we know where a lot of them are working. We know the companies that they're working at. There are some companies who will just be coming year after year looking for graduates because they're happy with the quality of the people that they've hired. Whether they're land surveying or engineering consultancies, or in my case, in the navigation positioning area, we have there are companies that have maybe about mid-sized companies with 100 employees, and a quarter of their technical staff are your graduates, either from the undergrad or graduate geomatics program. So, Tim used the term family, and I would say absolutely that works because we do know everyone by name, and people do keep in touch. The program this year is celebrating its 20th year. So we've been at York for quite a while, all three of us that are on the call. And so we we keep in touch with folks who are now senior managers who graduated from even that first class, or in Guno's case, he has one graduate who is a professor at another university, and Costas could list off others. So in terms of geomatics across Canada and around the world, it's a sizable but still close-knit community. So we keep in touch with people quite well. And we can talk about what courses are like and other things, but I'd leave it to other colleagues if they'd like to speak, or if people want to ask specific questions about what courses you'd take and what can you do with this degree, etc.
Okay, so that actually is my next topic that I want to kind of bring up. What are some of the topics that students learn in geomatics engineering? And could you describe a bit about them and give some examples of maybe real world application? And, whoever wants to tackle this can go first.
I'd probably defer to one of my other colleagues. I don't want to be doing all the talking. Costas, do you want to?
Sure. Some of the courses and some real applications. First of all, I think Professor Bisnath mentioned about GNSS. Professor Guno mentioned about data. I mentioned about information from imagery. A prime example of geomatics technology you have is your GPS navigator you have in your car. That what it does, right? It collects the data, right? So you use a positioning, receiver as a GPS, or use satellite positioning, then uses maps that have been generated, from aerial or satellite or terrestrial data collection methods, integrates the data, and then it provides you spatial awareness and intelligence. By doing some spatial analysis, you say, I want to go from point A to point B. So this is a prime application of geomatics engineering. Other applications, for example, we had people working at the tunneling of the LRT, in the east-west corridor. So the geomatics engineering people were there to ensure that the direction of the tunneling and the dimensions of the tunneling were correct, because remember, they were underground. So that means underground, there is no GPS reception, right? So they were using serrain methods to do this work and measurements, and that included not only the positioning and the direction determination, but also any deformations that we will have based on the walls. Other application, Professor Guno maybe talked about that, is indoor position. We have graduate students that they develop systems for indoor positioning in areas such as the shopping malls, and maybe Professor Guno can say a few things. I believe he has a couple of his graduate students working that, and the list goes on. Guno, do you want to say a few things about that?
Right. Okay, the guys. So the question is, what we learn from the classes and what we'll killing applications, and
Basically,
we're
more or
going to
less.
develop as a geomatics engineer. Okay. So I think the course scenario covers a lot, and I'm teaching 2 courses and how to analyze a data set. For example, it's one of the example. If you go to the civil engineering and you're considering about the flooding, you might be studying more mechanicals and flood, the simulations, modeling, how to prevent this flood, and physically, and what the geomatics, for example, and we sort of developing the sensors, and collecting the data set, we trying to understand and analyzing the data set, and working with government and civil engineers for helping them where the problem's happening and where people located more capital for preventing them. So basically those, I don't know, this is a good example, but if you're a little bit confused about the geomatics from other field, and this is some, one way to see the geomatics is we collecting the data set and analyzing them, but those data sets are related to urbans and cities and environments. And we're working with engineers who built the critical infrastructure. We help them and to manage well. This is one of the examples that, two courses that I'm teaching, and then this year's, and we have a mobility justice. That is a theme for the project. So we're collecting the open data set from London and New York's taxi drivers and Uber movement data set, and a lot of open data set city released to the public. So we understand the nature of this movement. And so, for example, how we to build the bicycle sharing station better, and so that people more sharing them. And that is one of the topic that students have chosen. And the other students, like a safety or accessibility of the pedestrians, particularly in pandemic situation, and where we're going to put more bicycle lanes. So those are the, one of the small examples that we have questions, and we are addressing them as a part of the project. And as students are graduated working in, obviously, city of Mississaugas and even the York universities, and who needs those data analytics, and governments building GIS specialist positions for who can actually deal with this data set. Okay, so that's a sort of a one, two courses that I'm teaching, and including programmings and database, and the project-based courses, and you have a hands-on skill for building apps and many other tools, but basically, and recommending them, and how we more effectively using city resources. Okay, so that's a sort of what I'm teaching now, and I think that's enough, isn't it? I can
Yeah,
do more.
I mean, I'm sure we can all talk about like for days about any of these questions because we all love science and engineering. But yeah, I think those all three of those answers were very, very good, and I think I learned a lot myself from hearing that. Now, I would like to now move on and kind of to this topic, and it's one that I'm also very curious about, and I'm sure lots of people are, and it's that what are kind of the differences, but also the similarities between civil engineering and geomatics?
Since we're going around, it seems, in a circle, I guess I can go. And it actually follows off quite well what Professor Hassan was talking about. We get this question a lot, and there's a good reason for it. So if we go back, sorry, I sound like a professor. My 8-year-old will say I'm lecturing. I don't mean to, but just to make it interesting. So if we go back, to the end of the Second World War, where we went through the war, all this technology developed, but then we have the post-war reconstruction and building booms in North America and all over the world, as we think we'll see once this pandemic's over and we get back to normal life, and we'll see this explosion, in getting back to normal life. Um, uh, Geomatics engineering, the old name would have been surveying and mapping engineering. And surveying was a branch of civil, and it had been for centuries. So civil has, its a structural component, the geotechnical component, transportation, environmental, that tend to be newer. And there was and surveying engineering was a branch of civil, or is actually. But what happened after World War II is we developed all this amazing new technology, airborne cameras. We started developing laser technology for making measurements that led to all kinds of stuff like LiDAR, much later GPS that I work with, trying to improve how GPS works every day, whether it's for your cell phone or for engineering surveys. Um, and what it meant is that a huge amount of technology and digital technology, computer technology. So smart digital maps that were a Canadian invention, if people have heard of GIS. These are courses that we teach at the undergrad and grad level. If you imagine, I don't know, Google Maps or Google Earth, all the technology that goes into that. Sure, it's a huge amount of computer science doing the processing, but where did the data come from? And how can you locate a street on that map? And where did the map come from? Aerial images, satellites, all kinds of things. How do we bring that all together? So geomatics is an offshoot of civil in that sense. what happened was that so much new technology, sensors, digitization appeared that it became very specialized, and we branched off into a separate field. All of the automation, all of the computer science, the coding, and the application of new sensors, and that's just accelerated. It just continues to accelerate, um, and it will continue to accelerate. And what we're seeing now is a lot of overlap. So when Professor San does work, he will have people from computer science who are involved, computer vision people. Sometimes when Professor Armanakis does work, he'll have people from environmental studies interacting. When I have work or when I do other projects, there are people from physics and other non-engineering departments as well, but it's applied science. And so this is how things have changed. So one of the biggest differences that you as an undergrad would see in second year is that right away there's a fair amount of programming, not the computer science programming that you've undergone in first year that you might like, or maybe you're groaning, I don't know. Some of you are computer science, so that's why I see the smile on our host, because I know his background. But it's more about coding. It's that we have algorithms, we want them coded up. We want to automate processes. We're not focused on the art of computer science. We're focused on a huge amount of digital data that we're trying to automate and make use of and understand to make decisions, because decisions is where the money is. So whether it's we produce people who can go out to be land surveyors, and they're producing maps, 2D, 3D maps for all kinds of construction, where they're working hand in hand with civil engineers, or they're working at the civil engineering firm or the engineering consultancy. To other areas where, as Professor San said, people are working at municipalities, working with very, very sophisticated digital mapping systems to help answer all kinds of questions, from how much your property tax should be to how quickly to get that pizza delivered to you. I mean, this is what the technology is used for. So a branch of civil, but that has developed very, very differently, and to the point when you look at courses, there's a huge amount of sensor focus, technology focus, and a great deal of coding rather than let's say programming. It's programming, but it's coding in various languages, MATLAB, Python now, that has really come online, very, very important, and interaction with a lot of specialized software and specialized sensors for all of these positioning, mapping, awareness, and decision making processes.
Okay, that was a very, very lovely and thoughtful description. I think definitely helped answer my question, and hopefully uh, everybody else kind of sees the difference now. I just want to take a little aside now and provide some thoughts that Timothy also left for us. One question a lot of people ask is, which classes, do people find interesting? And Tim's answer for this was he really liked his third year class about GIS, remote sensing, and image processing and surveying. And he also wanted me to share kind of one of his final projects that he did, where he was looking for hotspots in Toronto for COVID-19. And I'm just going to share my screen and show you a little bit of the work that he did and the figures he kind of made for this. I personally found it very interesting when he was describing it to me. He basically, took some data sets, mapped them. Everybody can see the screen, right? And he used a database system. He was trying to find where the hotspots are. He came to realize that, they're around the transit hubs and the industrial areas, more or less. And it's kind of like a little bit of even application of your computer science math, because essentially what we're doing here is we're intersecting the different layers of data, and then we arrive at a final interpretation of the results that these were the sort of hotspots for COVID cases in Toronto. And you can see that they're along the transit lines and in the downtown core and in the near the end stations of these lines. So just wanted to share that, and I found it very interesting that it's, very practical 30-year project that a student does, and I think anybody here is fair game for you to do it too. It would be a very, very good thing for you to learn and have on your resume, good skills that this program could potentially get you. Now, with that housekeeping and Tim's
Did he freeze?
message out of the way, sorry,
I think so.
did I
Sure, I don't know
freeze?
if you can hear us.
I
I
can
think
I
we're
can
all
hear.
okay.
I can hear. I stopped screen sharing.
Well, wait. Oh, there you go. He's back.
Yeah, very sorry about that. It happens. Hopefully, it didn't mess up the recording too much. But yeah, I had stopped screen sharing when I froze. I guess the next thing I'd kind of like to talk about is extracurriculars and competitions and uh, talks in geomatics, just different opportunities outside of the classroom that the panelists may be involved in or encourage people to get involved in.
Yeah. Costas, do you want to take that one?
Yeah, yeah, sure. I mean, first of all, on the student level, we have the Geomatics Club. Some of you may be familiar with that, or and I think it's open to the all geomatics engineering and geomatics science students. Competitions that we have, we participants, as you might have heard, or if you don't know, we are a center of excellence in geographic information system from the S3 Canada. S3 Canada is a GIS company that they market, the ArcGIS system. So we are one, I believe, of 15 center of excellence in the country. And every year our students participate in the App Challenge. And the App Challenge is to develop a geospatial application uh, that then is evaluated. Usually the students have a week to do so. They use open source software, open source data, and come up with these applications. We were very fortunate. We had a winning team a couple of years ago, and last year our team, your colleagues, got the second place. There is also the national geomatics competition that started in the last, I believe, 3-4 years, that takes place in the geomatics engineering and geomatics science program across the country. And this is organized by the Geomatics Club, and the students are participating. There are other competitions, like the national competitions in unmanned aerial vehicles. So far, we have not uh, participated. So far, we didn't have any teams from our program participating there. I believe that's what I have in mind. I don't know if I have missed anything. Sanil, Gunnar, maybe you can add.
Well, I don't know if it'll be a separate question, but when it comes to experiential learning, the summer jobs, co-op, whether it's a summer or a year, all of these are very popular just because of the industry demand. Um, there are a lot of jobs across a lot of sectors, whether they be in Toronto, public, private, small firms, larger ones, engineering consultancies. It's quite a range. So there's lots of room for experiential learning that the students get, whether it's they take jobs directly with companies, because we do attend some annual trade fairs. We have a career fair that we do together between the geomatics engineering program and the civil engineering program. Um, and there are always a lot of employers who are looking for people either for summer or some work part time, but that's always tough with an engineering degree, or the longer, 1 year co-op or beyond. And so employers are always looking for good employees, especially during summer construction season, but also just to get to know students that they're willing to hire, because there's an ongoing shortage. There always has been. Some of it is field work. Much of it is office work. And keep in mind that, once someone finishes and goes through their articling or training process, depending what kind of career they choose, they will be managers, and they'll be in offices in front of computers, as most engineers end up being. So I think that's an important component of some of the activities that the undergrads do, and it's terrific because they come back to class after second year and third year with very different views on what's important. They tend to pay attention a lot more because you have a much better sense of what you're going to do when you leave York.
I'd like to also pose the question about what to watch out for in terms of maybe scheduling and what course to maybe take in what semester in case people don't delay their degree by accidentally forgetting a course or dropping a course. Are there any specific topics or courses that are offered only at certain times?
I guess I can address that one really quickly. I mean, because of the nature of the program, that there are most of our third, fourth year courses have lab components because they're all very practical. And they tend to be more project based and group based. They're offered, one time a year. So what students tend to do is, technical electives, and this happens with most programs, technical electives or some of the Eng-K courses that might be offered again in the summertime, or computing courses they can take outside of the fall and winter terms to help them lighten the load. That's what we see a lot of the students doing, if they're able to. But then again, a lot like to try to work to get the experience in the summer, and they like to get some money as well in the summer because the jobs are quite well paid, given people are going in without an undergrad degree. So there's that mix where people are just following through the program, and others who try to go down from 6 courses to 5 by taking one of the Eng-4K or the design courses, or a technical, or an elective outside of the normal stream.
How does some of the surveying courses work? Like, what can a student expect, and how much time or kind of logistics should they prearrange to do these surveying course? Because to my understanding, some of them are offered summer only, others fall only. How would some of that work?
Costas, do you want me to address that, or do you, since you're one of the instructors this year?
No. Please go ahead. Please go
Yeah,
ahead.
but it's very quick. So unlike many of the other programs, we have 2 additional courses. That is one at the end of second year and one at the end of third year, and these are practicums. They're 2-week courses that are just making use of all the knowledge they gain from other theoretical courses. So they're survey field courses held at the York Yale campus. So it's to use all of the very advanced equipment to get practice in that, and then to produce maps, plans, etc. Digitally at the end of those. The courses are very short; they're compressed. They're all day for 2 weeks, so they are technically summer courses, but we run them right at the end of exams, and in some cases, not this year because of COVID. We have all these COVID restrictions we all have to live with. But we'll tend to try to start them as soon as all the students in the class finish their exams, because people want to start the courses and finish them as soon as possible. Sometimes just even run them over the weekend so people get head off to their summer vacation or their co-op jobs or whatnot. The students do find this beneficial because employers, if they want to, let's say, have a job in construction in the summer, they can tell the employer, look, I have this and this. I have this experience. I know how to use this equipment, or I can do these types of surveys, and that helps them get the jobs because they're coming with experience, even though it's quite limited. It's just on campus, but they're able to get up to speed pretty quickly if they're working on a construction site or something like that, or if they're working in the office with certain software, they've used some of the software because the two courses are practical. So right at the end of second year, right at the end of third year, 2 weeks, beginning to end, with whatever. There aren't really exams, right? There's submission of final reports and plans and whatnot. So they will be done quite quickly. This year with COVID, it's a bit different because the courses they're being stacked together, etc. But on a typical year, yeah, it just takes you 2 weeks after the end of exams, or maybe slightly overlapped with exams. Some other programs have such field courses. For example, space engineering has a hardware field course off at an observatory that runs a couple of weeks. So they have one, and I'm not sure if others do. Civil, for example, has a survey field course. We run it for them, and it's an abridged version of the course that we do in geomatics. And so they have one at the end of second year as well that we run, and it's similar in nature. It's not as detailed. It's different because it's for a wider group of civil engineers. So they also have one extra course, and I can't really speak for mechanical or computer or software if there are any. I don't know if they have any practicums at the end of the winter term. But as I said, civil and space each have one, and geomatics has two.
Yeah, okay. So on the notion of the civil, or sorry, the software and computer, not really any practicum in kind of like that style that you just talked about. It's more just standard project-based class, like the whole semester. You have like a group and you kind of give a final submission as what the project was, kind of like a mini capstone. But yeah, so essentially, what I think we should all take away from that is, in civil, geomatics, and space even, you do have that choice of doing like a full week, kind of full 2 weeks of basically. So I would like to think of it as practical training, even, because you do it the whole day. I would like to think that, if you go in for like 5 to 8 hours a day and kind of learn something all day, the learning is slightly different, right? Versus if you do 4 hours of lecture a week or whatever, and it's segmented and broken up. I do think that that's another good selling feature for these courses, and that would be the main reason why I would pick geomatics if I was considering it, if I could go back in time. But I guess it's too late for that now, because I'm even being convinced from this now. So on that note, I would like to open up the floor and ask our audience, please do take this opportunity to kind of ask any questions, specifics that you have of your own. Just raise your hand or unmute. We're all friends here, no one bites. But yeah. Vincent, go ahead.
Yeah, sure. I'll ask my question. I guess my question is just like how I think a lot of people are confused about what's life after a geomatics degree, especially in the job market. I think because since we're so since there's a whole conversation between the difference between civil and geomatics. What makes geomatics unique, and what kind of advantage does that give geomatics students in the job market?
Yeah. I hope one of my colleagues that I answer. I will, but I just don't want to be the only one speaking. Guno, would you like to respond, or would you like me to?
Well, I want to make one comment, but you can follow it up. And I say it's very largely different. For example, in terms of curriculums, if you're interested in programs, if you're interested in data handling and sort of computer science and engineering, but as well as civil engineering, right? And the civil engineering, I don't think there is no the courses that you educated through the how to programs and how to deal with the data. So there's more structural engineering and the design, the bridges and dams, and environmental engineering and a transportation engineering, right? But the geomatics is the central part of geomatics is, and we're dealing with those civil data, right? And data needed for civil engineering, not only for civil engineering, but data needed for civil engineering. We more concentrated, more focused on sort of how to program, how to analyze it, how to build that data analytics tools and system, and for addressing the applications required as civil engineering. Okay. And what about the computer engineering? So computer engineering is focused on the software engineering, how to build the software, to make the robots and the things. But they're not the studies about how this software they build and its importance for environment, importance for society. So the geomatics is sort of a balance is out. We dealing with this data and programming, but and also as well as heavy understanding is about the urban problems, societal problems, and a critical engineering problem, right? So there's more digital engineering. That's what biggest differences for me. Okay, maybe you can, the Sunny can power it up.
Sure. Thanks. Thanks, Kuno. Yeah. So to that question of what do people do with this degree? What can they do? I'd start off and end with the same thing: is that there's an incredible shortage of geomatics engineers in companies in and around Toronto, the GTA, Ontario, the country, and beyond. So our graduates, it's not a matter of if they get a job offer, it's a matter of picking from a job offer. And this has been the case for years and years and years, even during slowdowns. So we're going through the COVID crisis. Myself and my colleagues, consistently get emails from companies, from colleagues looking for people because the work, for example, let's say in the surveying area, the construction, it didn't stop. It hasn't stopped during COVID. So incredibly great job market. It's not a huge job market, but you heard about our class sizes, they're small. So we've had some folks from bigger companies, that have hundreds of employees that would say, hey, we would hire, a class of 50 today if there were 50. If there were 15, we'd take those 15. And, that would be a single company, a single employer. The reason is because of the specializations, is having knowledge of the sensors, the software, the technology, and be able to use it the way that Professor Sans described. So where do the students go? A good number of the students will go to the land surveying field. That is mostly cadastral surveying, that is boundary surveys, which can be very lucrative because in Ontario and in Canada, the only people who can set boundaries are surveyors by law. It says that in, the Surveying Act. So if you're building anything from a bridge to a condo to a house or proportioning a house, only a surveyor can do that. Then there are the engineering surveys and some of the work that Professor Armanakis talked about. So building a new subway line or monitoring, when we're building large buildings or putting in new railway lines, or all of this, any big work needs engineering surveys. And they're very, very specialized, and they're not easy to do. So the training that people get here, they can go work for these companies. In the geospatial side, we call it, or the digital mapping side, whether it's private companies, municipalities, governments, they're always looking for staff that have very, very specialized knowledge and use of particular software, and that are able to know how to use them and how to do the kind of analysis that was shown with Tim's work. And then there's a host of other companies, from startups to larger development companies that develop systems and technologies for everything from improved digital maps for the type of apps that you'd see on your Android or iPhone, to building components or intelligence for autonomous vehicle systems, or autonomous unmanned aerial systems, such as the one behind Professor Armanakis. So something that Professor Son had said, and I'll end with this, aside from saying, there's so many jobs and not enough of us out there. because think of it this way: with so much of this work, you would have all of the graduates from civil and computer science, and this is no knock to them. Everybody at Lasson's doing a great job, but companies would end up hiring, civil engineers, and then have to train them to do geomatics work because there's a shortage of geomatics engineers. And the same with civil, the same with computer. So you'll have people who graduate computer science degrees who would then have to learn about all these specific technologies, because they're working for a particular company. And that would happen if they work for all kinds of different companies. And in our case, we are training them to do all of this work. They're not particularly great computer scientists, but they're really good coders, or they know they don't need that particular training, in these niche areas, and that's the difference. And so that's what we see happening in industry. So people will say, hey, we're looking for somebody who can do this, and typically it might be a computer scientist that's applying. And then when they hear that somebody has this background, they're like, well, we don't have to train them, they have all the background we need, or most of the background. And so there's less training involved. And that's where, that's why there's this excellent job and career market. And these are, people tend to think, when they think of something like land surveying, they think of the guy that's on the street. That's a survey technician. That's the person who went to a community college, and they're out collecting the data. The surveyor you almost never see, because they're in the office signing plans, and you'd be amazed how much money they make signing a boundary survey, because you all realize how valuable land is in Toronto, as an example. So that's the other part of the thing, with many engineers and many branches and many of the departments at Lassonde, people never actually see them, whether it's geomatics or space, or, people will always ask, what's the difference between software engineering and computer engineering? It's because the public doesn't actually see us in all these branches of engineering outside. So it's very hard for them to understand what we do. They think of mechanical engineering and they think of gears and whatnot. Well, we don't really teach any of that stuff in mechanical engineering. We haven't for decades. They're studying fluid dynamics, and they're working on medical devices. This is not what the general public thinks that's happening in mechanical, and it very much the same in geomatics. Yeah, so there's no shortage of jobs, but more careers, and really, really good careers.
Just to add, if I may, Hasir, just I think few months ago, a company approached us looking for geomatics engineer, and the topic, the objective of the job is to use laser scanning, right, to model mechanical engineering installation. So essentially, use a laser scanning, collect the data, collect point clouds, and then generate 3 models of the machinery. So essentially, it was mapping of machinery using laser scanning, and they were looking geomatics engineer to do that work.
It's a lot to think about. So you've brought up coding, and I guess this will be the last recorded question as well, but you've brought up kind of coding and the other fields as well. In geomatics, can people expect to maybe apply some of the stuff they've learned in maybe MATLAB? And will they also have to do any sort of AutoCAD and modeling, or there's no modeling?
Absolutely. MATLAB for the very basic, which students like to use because it's easy. Python has just continued to grow in popularity. So for a lot of the software, the advanced mapping and the digital presentation, the digital map software, the interactions will be in Python now. Professor Armanakis and Professor Sonnet talked about it. So if people are developing apps or for phones, or developing APIs for software, they're doing them in these languages. Modern, such things as Python. So pretty much in every course, students are making use of coding. That is, taking algorithms and automating them, and that's happening in pretty much every course. It's all very, very practical. And by the time when we move to the graduate level, Like, for example, in my lab, and I run a satellite navigation lab, the satellite navigation lab at York, and others can speak to this. The master's, PhD, and postdocs, they're all, it's C++, because there is that understanding, but it's the industry standard for us. Everything's under version control, and who knows all the different components that they're using, from such things as GitHub, Jira to run projects, etc. So we do pretty much run the industry standards for project management and software development, just because if you have half a dozen people or a dozen people working on software, everybody's got to be able to check out functions and put them back in and continue and do that. But that's more at the graduate level, but that's the sort of the propagation through the undergrad levels. But again, for everyone on this call at the undergrad level, it's all very practical. The idea is what you're using, what you're learning, you're using. So most of it's focused on math and the programming or the coding skills, and the application to a lot of new technologies and sensors, techniques, and very advanced software.
Oh, okay. So I'm gonna stop the recording there, and I think we've answered a lot of good questions. I think everybody's really learned a lot, but I'm just gonna stop the recording there and let the floor be open to anybody who doesn't want to ask their question on the recording. And I think if we feel that everything has been answered and we're good with it, we can all have a nice sign off and wish each other a great day. Before I end it, I'd just like to say thank you very, very much to our panelists and all of our guests for coming to this event. It's really, really tough to organize stuff like this. And when it all comes together, it really does kind of give everyone hope. When we come back, we're going to see people and say, hey, I saw you on camera, I remember your face, we had a good conversation, it's nice to finally meet you. So I really do encourage everyone who's in this call, if you see anybody in the call again, please reach out to them and say hi, go for a chat. It's always a nice thing.